this video, I want to talk about how we know whether a given value of x is a solution to a compound inequality. Because in a moment, we're going to start solving compound inequalities, and our answers are going to be either an interval or maybe two intervals, or it's going to be a whole host of values. And any numbers of x within that interval are technically a solution. So when we say they're a solution, what does that mean? Okay, so for example, this is a compound inequality, 2x plus 1 greater than or equal to 4, and 1 minus x less than or equal to 3. And I want to know if x is equal to negative 2 or if x is equal to 3, if either one of those constitute a solution. All right, so with this word and, remember, and means intersection. So that means that if I stick a value in here, it means that it will work in both equations if it is indeed in the solution set. Okay, so how would we check that? Well, how would you check any solution? You just take the value of x and you put it into the equation and you see if you get a true statement, right? All right, so we're going to say 2 times negative 2 plus 1 greater than or equal to 4. I want to know if that's true. So I got negative 4 plus 1, that's negative 3. Is that greater than or equal to 4? No. So right away, I know that x equal negative 2 is not a solution. I could check it in the other one if you want to. It might be true over here. So 1 plus 2 is 3. 3 is less than or equal to 3. That's true, but it's not a solution because it doesn't work in both of them, right? So we'd have to say x equal negative 2 is not a solution. Okay. Now, what about x equal 3? Okay, so now if we try x equal 3, again, plug this one in, see if you get true statements. So 6 and 1 is 7. 7 greater than or equal to 4? Sure thing. Okay, 1 minus 3, is that less than or equal to 3? You bet. Negative 2 is less than or equal to 3. Okay, so since it works for both, we could say that x equal 3 is a solution. Okay, all right, but that's the question you want to be asking yourself. Does it work in both equations? If it doesn't work in one or the other, then it can't be a solution. Okay. Now, in this example, same directions here. We're trying to determine whether or not these two values of x are indeed solutions. We have an or statement here. Yeah. So that means that it has to work in at least one of them. It has to work in one or the other or both. If any of those apply, then it's a solution. So if we check negative 5, let's put negative 5 into both of these and just see if it works. So negative 5 plus 1, negative 4 is less than or equal to negative 4. That's a true statement. And now how about over here? Negative 5 plus 1, is that greater than or equal to 4? No, I'm afraid not, right? But in this scenario, because of that or statement, x equal negative 5 is a solution. So with that or statement, it's got to work in at least one of them or in both, right? So remember that or means one or the other or both. Okay, so now let's check 2. 2 plus 1 less than or equal to negative 4. Is that true? Nope, it's not. 3 is not less than or equal to negative 4. Okay, how about 2 plus 1? Nope, that's not true either. If it's not true for either one of them, can it be a solution? No. X equal 2 is not a solution. Okay, so next up we're going to start solving some of these and take a look at what that means and how to denote solutions.